or automated driving, as I prefer to call them, and things like that. But we can probably tease out a little bit more of that as we work through. But yeah, I'm just an automotive man through and through, you know, who've just done different sorts of careers.
Yeah, no, that's excellent. Yeah, it's brilliant. Really good to hear. I'm kind of over to you, Ben.
Yeah, similar. I'm a proper automotive bobble hat. I describe myself as, really. I started off, as an apprenticeship with doing an apprenticeship with BMW, my local dealership in my hometown of Shrewsbury, and towards the end of that, I was ever so lucky, and I got an opportunity to work in Formula One. So I became a Formula One mechanic at the age of 20, and was a gearbox mechanic and a sub-assembly mechanic, which essentially means getting all of the small bits that come out of the machine shop and assembling them into lumps that are about this big, and then giving them to the mechanics that then put those components together to make the car. Became a traveling sub-assembler, so I used to travel around the world a bit, and I used to do left front off in the pit stop sometimes. And then my team went bust. My team was a team called Arrow's Formula One team, and we'd been around for years and years and years, and we never won a race. We were one of those teams. So we were probably, because we'd been around for such a long period of time, probably the most unsuccessful Formula One team of all time. However, it was still a wonderful car and a wonderful fast piece of equipment, and I learned lots and lots, and it was a amazing experience. I was so lucky. But the team went bust in 2002, and I just had a thing for teaching, and I had a sneaking suspicion that I wanted my own business as well, and I became a contractor, and I started writing and delivering training courses for various different manufacturers, and a few other customers as well. Started an apprenticeship training company then in 2003 with a few of my colleagues, and that sort of did pretty well. And then I saw that there was a good opportunity in China, so I moved over to China, and I became a consultant over there, writing and designing training programs for some motor vehicle manufacturers over there. And while I was over there, it became clear to me that there was an opportunity to move into online training. So we honed our skills over in China in how to write online training courses and what have you. We set up a studio in the UK, and then in 2016 we launched our website, our virtualacademy.com, and that's what I'm still doing now alongside my team. So what that means, thinking about it from a technical perspective, is we research systems on vehicles, and we design methods of teaching those systems, and we make a video in the studio and green screen it and things, and then my editors will make all of the various graphics, and we'll join all of those dots together, and we'll end up with a video, and we'll release it on our website, and then our customers gain access to that training. When it comes to electric vehicle, I was very fortunate, really. I was contracting. One of my very first contracts when I had left F1 was writing the Toyota Prius training material for Toyota. That was at the end of 2003. So that was the second generation Toyota Prius. So I got my hands involved in high voltage systems from quite an early stage, which was great. And I felt that was the future then, and I knew it was a good subject to make sure I stayed up to date with as much as I possibly could, and have continued ever since, and have been very lucky, worked on all sorts of high voltage vehicles. I'd say the most exciting high voltage vehicle was the Porsche 918 Spider. That was amazing. While I was over in China, Porsche Germany sent over that vehicle to us for a team of about 8 of us to pull it apart. And that's what we got to do. And we pretty much stripped it down to its bare bones and put it back together and got a really good understanding of that. And essentially, any opportunity I've had to research and learn more and write more about hybrid and electric vehicles, I've absolutely done. So when I got the invite to this presentation today, I was, you know, rather enthused when I saw what the subject was, and here I am.
Excellent. No, yeah, perfect. Both amazing kind of backstories, really, and so much experience. I would say, kind of in the automotive world, and you know, it's a privilege for us both as a college and kind of with the students we have to have you both involved today. So yeah, first of all, thank you very much on behalf of myself and the college for joining us. It's very much appreciated.
An absolute pleasure.
Yeah, I just wanted to kind of say that, really. So kind of, yeah, keen to kind of get it kind of rolling off, really. So we've got a range of different students, as I kind of mentioned, some that may have a really good understanding of electric vehicles, some that have no idea, maybe just seen a Nissan Leaf driving around and those kinds of things. So first of all, kind of like to kind of say, you know, what is an electric vehicle? What makes an electric vehicle? How is it powered? You know, the differences in with it being some may have heard of a hybrid system. So kind of if I go to Tom, how would you kind of class what an electric vehicle is? Like what actually is one?
Okay, I'll start at the very beginning, I think, but I'd also take the opportunity that I forgot to mention before, what a massive Formula One fan I also am. And there's a subtle link there, of course, because as a lot of people will know, all Formula One cars at the moment are hybrid cars. So there's a lot of interesting, you know, high voltage and hybrid technology comes down. And I can't resist the opportunity to show you my Niki Lauda's hat that is signed by Lewis Hamilton. So that's, you know, I just thought I'd drop that in there. I mean, it's not relevant to what's going on.
I think we have quite a few Formula One fans in the chat, maybe.
There you go. I'll drop that in. So what is an electric car? Let's start with a little bit of history. I mean, might be interesting. I'm not sure if I'm going to get all the dates exactly right, but I think, for example, the land speed record in something like 1895, give or take a bit, so more than 100 years ago, the land speed record was held by an electric vehicle. And you know, so that's when they've been around from. So even earlier than that, if you go back to kind of, you know, electric trams and all sorts of things like that, and so on. And then they developed, and of course, those of us that are kind of old might remember, and there's still a few of them about, electric milk floats. So little trucks that used to bring the milk to your door. I mean, how weird is that? You know, what? Why did you have milk to the door? Why not just pick it up at Sainsbury's like the rest of us do? But there you go. So all of these technologies developed, and in actual fact, well over 100 years ago, electric vehicles were starting to advance quite a lot. Now, you can wonder why they didn't advance as quickly as they could. And you could wonder why some big oil companies might have wanted to sell a lot of petrol, for example, and therefore it was more advantageous to them to be creating internal combustion engines. But, you know, without turning this into a social history, let's go back and sort of think what an electric car actually is. But I just thought it was useful to say that, you know, this technology is not brand new. Some of the clever ways that we're doing it and the clever ways that we're working is amazing and is brand new, you know, and I'm sure Ben and I between us will come to bits of that later on. But an electric car, I mean, it's, you know, it has a wheel at each corner and a steering wheel in the middle and brakes and suspension and everything else that, you know, you think of as the normal car, whatever that is, has, except that the drive is created from a battery and a motor. So, you know, we've all had sort of toy cars in the past that have had sort of, you know, a couple of Duracell batteries in the back, and, you know, you set them going and they might be remote controlled or whatever. That's an electric car, you know. So we've taken that idea and scaled it up. And of course, in scaling it up, you make things like the motor, the electric motor, much more powerful, much stronger, hugely powerful magnets, for example, you know, high voltages, so you can get a lot of electricity in a short time, and different things like that. But in simple terms, an electric car simply has a battery that drives a motor that makes the wheels go around. You know, that's a nice simple definition to get going. Now we need to add, of course, all sorts of controls and things on top of that. But perhaps if I stop there, I don't know if Ben wants to dive in and sort of continue the story, so we sort of do it between us. Perhaps might be a nice way, Ben.
Yeah, with pleasure. Yeah. So I mean, I suppose I'd chuck in that for it to be a true electric vehicle, we're talking a minimum of voltages above 60 volts. And once we've hit that threshold of more than 60 volts, then we are really dealing with a high voltage vehicle. And I'm finding myself using terms like high voltage more instead of referring to hybrid and electric vehicles, simply because it allows us to merge those two together. And it also bypasses some of the technologies that are a little bit more of a marketing phrase, such as micro hybrids and to a degree mild hybrids as well. So true hybrid and electric vehicles that can power a vehicle along enough, a minimum of 60 volts, and in general we're talking a minimum of probably about 160 on around the sort of ballpark for some of your Honda lower voltage systems, and then they're creeping up to sort of 400 volt battery packs on modern systems that can operate at 800 volts as well. So I'll just add that into the mix. Regarding the sort of technology, I suppose if we go a little bit further thinking along those lines, so we've got this high voltage battery pack, which in many instances is filled with conventional looking batteries that, you know, you might have seen in the back of a big radio or something along those lines. Well, instead of it having 3 like you might find in a big radio, then you might be talking, no, I'm making the number up a little bit, but you might be talking 1,000 on a very high battery pack assembly. So you've got that many all together, some of them wired in series, some of them wired in parallel, to give you both the capacity for the amount of range required and the levels of voltage to ensure that we've got the levels of torque required out of those high voltage motors. So then moving on from that high voltage battery pack, we've got some relay assemblies, which are allowing us to electrically disconnect that high voltage battery from the rest of the vehicle. Sometimes they're called contactors, sometimes they're called system main relays. They're the same sort of thing, really. And then from feeding that high voltage past those relays, we're then going into something called an inverter assembly. So what the inverter is doing is it's inverting the direct current that we get out of a high voltage battery into a digitally controlled and computer created AC voltage, and that AC is then applying current along different windings inside the high voltage motors that have normally got these very powerful neodymium rare earth magnets embedded in them, and that gives us our drive. And then in reverse, one of the beauties of these systems is that they're able to retain energy within the vehicle quite well. And when a vehicle is moving along, it carries a certain amount of energy. You know, even if we're thinking about a normal car that's not electric and it's got an engine and a clutch in it, you know, if you think about it, if you're driving along at 50 miles an hour for the sake of argument and you put the clutch in, that vehicle is going to continue rolling and it's going to eventually stop. But for a period of time, it's going to be rolling. Same as on a bike if you stop pedaling. Well, that means that energy is being held within that vehicle while it is freewheeling, as it were, and just slowly slowing down. Now, on a conventional vehicle, if we want to slow down, we press on the brake pedal, and the braking system is actually converting this kinetic energy, this energy stored in a moving body, into heat. And through losing that energy to heat, we slow a vehicle down. Now, when thinking about high voltage vehicles, what they try and do as much as possible is not use the conventional braking system to create heat and transfer kinetic energy into this heat. What they'd much prefer to do is make the motor work in reverse, as it were. Now, when I say reverse, it's still turning in a forward direction, but instead of it having current put into it, electricity put into it, it's able to perform as a generator, which in turn outputs electricity. And because it's converting kinetic energy into electricity, it's putting a resistance against the wheels, and it causes the vehicle to slow down. But in the process of doing that, instead of wasting that kinetic energy and turning it into heat, we are using that kinetic energy and turning it into electricity. We're essentially generating electricity for free. So now that we're generating some electricity for free, that AC electricity that's generated at the motor for free is then passed back into the inverter assembly, which converts it from AC to DC, and then it puts that DC electricity back in the battery and gives us a further level of efficiency in the drivetrain, which is, you know, one of the main reasons why this technology came out in the first place.
No, that's absolutely brilliant. And, you know, huge kind of technical kind of background with what a high voltage vehicle is, and, you know, that's absolutely brilliant. And yeah, it's one of those, I think, misconceptions from when you start learning about electric vehicles, what the battery's made of. You know, is it a big kind of wet cell battery that, you know, is it a massive lead acid battery where you have lots of cells, but it's not actually, is it? You know, it's all these little standard, I think it's like 1850, I can't remember the full code of the battery, but yeah, it's all these little ones put together, as you said, in series and parallel, which make it up.
Yeah, there are instances where they are not always like that. There are square versions of those, but, you know, in many cases we are talking like these D cells.
Yeah.
Like you're chucking in a battery. And then I suppose there was one bit that I didn't say to finish off your question, and that was, you know, I was talking about a high voltage vehicle, and a hybrid is a high voltage vehicle, and an electric vehicle is a high voltage vehicle. But the difference between those two is that a full EV, a BEV is the most common term, which is battery electric vehicle, that does not have a combustion engine, be it diesel or petrol. You don't have that. So you've simply got your battery, inverter, motor as the main parts of your drivetrain. Whereas with a hybrid, it's a hybrid of two power sources. So that means that we've got two energy sources which exist on that vehicle. The one energy source is the high voltage battery, and the secondary energy source is the fuel tank. So that means we've got the capability with hybrid to be able to run the vehicle on, we'll have to squint slightly with this statement, but run the vehicle purely on engine power, or purely on electric power, or purely on the two. And so the sort of advantage with hybrids is that, of course, you don't have a problem of range anxiety, i.e., if you are running out of electricity in your battery, you can always pull into the fuel station and fill up your tank, and you can drive that vehicle pretty normally. Whereas, of course, with electric, you've always got to make sure that your battery is sufficiently well charged to complete your journey. And so, you know, because range anxiety is a thing, and it's only been in the last few years, really, you know, the last sort of 9 years, I'd guess, probably when about the Tesla S came out, that we've been seeing the longer ranges. That has really meant that, you know, say business travelers like me and Tom perhaps could get away with driving a full electric vehicle as opposed to going down the route of an internal combustion engine vehicle or a hybrid.
Yeah, and kind of coming back to, sorry, Tom.
Well, I was just going to suggest, I mean, it's probably what you're going to say, Vinny, but I pick up, Ben dropped in a couple of terms along the way there, and that was great, obviously, but I thought perhaps it would be useful now that we're on the subject of hybrids, to just quickly explain that there are different varieties of hybrids. Now, as anybody who works for a vehicle manufacturer will know, different manufacturers have different ways of explaining things. So this will be the version according to Tom, okay? But it's probably not far off the real kind of thing, really. So, let's start where Ben left off, really, with the what he described quite rightly as a BEV, or a battery electric vehicle, and sometimes called a pure electric vehicle. This is, words go wrong all the time here. And then we sort of move into the hybrids. So as Ben rightly said, I don't expect anything other, you've got two power sources, hybridizing them together, a petrol engine usually, and an electric motor side by side. And there are a number of different ways that these things can be configured with these motors and engines in what's known as series and parallel. But I think we'll probably leave that for another time, because that's starting to dig deeper. But the main types of hybrid, as I kind of think of them anyway, really, we can start right at the bottom with what's sometimes called a micro hybrid. And a micro hybrid will have potentially bolted onto the side of the engine a little thing that can be thought of as a combined alternator and motor of some description, so that from a battery that, as Ben also suggested earlier, could be around about 48, 50, 60 volts or something like that. It'll supply electrical energy from a battery, and that battery won't be much bigger than a standard big 12-volt car battery, but it will supply enough to just add a little bit of extra torque into the vehicle. It makes it very easy for a stop-start system, for example, so that you stop the car at traffic lights, and then the electric motor is just enough to sort of get the car starting to move and starting the engine at the same time and things like that. But it also, importantly, does what Ben also suggested, this thing called regenerative braking, so that when you're slowing the vehicle down, there's an opportunity to recover some of the energy that we normally throw away. But to be quite honest, the micro hybrids are a way of sort of getting round some legislation towards the future, I think. I don't think they have a longer term future with them. The next sort of hybrid that I think of, and this word definitely gets used differently, but is a mild hybrid, where you would have an engine and an electric motor, but that the vehicle is not capable of running on electricity only. The things are definitely combined. The early Prius, I think, were like this, but definitely the early Hondas were, and things like that. Then the next step up from that is what I think of as a strong hybrid. And a strong hybrid is able to run on the motor or the engine, or a combination of the two. So we're kind of going up the tree. The next one up, if you like, from this is what's called a plug-in hybrid electric vehicle, PHEV, and that's what I currently drive, actually, a plug-in hybrid. And that has a battery, fairly substantial battery. And again, we'll perhaps talk another time, if we come back, about how batteries are rated in kilowatt hours and things like that. But for the time being, a fairly substantial battery, and this particular car will do about, depending on the time of year, temperature and things, 20 to 30 miles on pure electric. And then, of course, when the battery runs out, the engine just takes over, and it's got a normal tank full of fuel at the back, and on it goes. And it's been rather interesting, actually, over this past year, as we haven't been going out very much in the year, is that I have run my plug-in hybrid car almost purely on electric for about a year, because I haven't been doing long journeys and so on. And it's been quite interesting to notice the change. So that's the sort of range, if you like, of hybrids. So we start with micro, mild, strong, plug-in hybrid, and then, of course, up to the full electric vehicle. And I've got to get one more thing off my chest while I'm here, and some of you will know what it's going to be, and that's the thing called a self-charging hybrid. It doesn't exist. There is no such thing as a self-charging hybrid. All hybrids, as Ben suggested earlier, in the same way as a pure electric vehicle, their real advantage is that they will collect energy that we normally throw away in braking and put it back in the battery. That's a nice simple way of thinking about it. And the latest cars that are described as self-charging hybrids, that's what they do. They don't get energy from anywhere else. So the energy that is in their battery can only ever come from the petrol that's in the tank. So it's a bit of naughty marketing, I'm afraid, and it drives me mad, and I'm not going to mention it ever again.
That's brilliant. Thank you. Yeah, I mean, that's really, yeah. So from the very early stages of, we spoke about milk carts and all the way up to now talking about micro and full and plug-in hybrids. I think that's really given a good range, I would say, for anyone that didn't know before, or maybe knew a little bit. It's really kind of given a good base knowledge now to show kind of what it is, what these high voltage electric vehicles, etc., are kind of involved really. And kind of picking up on kind of what you said, Ben, about range anxiety. And there was a program on ITV, I think, Tom, you might have seen it, I'm not sure if Ben, you've seen it, where they went around and gone to charge their vehicle up, and then went to one station, it was faulty, went to another station, it was faulty. And it's this infrastructure we have in our country at the moment, which I think is giving a lot of people some concerns about buying a full electric vehicle. Where do we have the infrastructure in place to go out, and if you have a 200-mile range, are you constantly going to be worrying about, can you charge it? Or if I get to somewhere and the charging stations aren't working, for example, it's those kinds of challenges, I think, sometimes out of our hands as kind of training kind of areas that we can't really control, but until these kind of areas come into it. But also cost. I ran a poll on LinkedIn a while back, and the main reason for an objection to buying a hybrid or a full electric vehicle was the cost. And I think I've seen somewhere on some of the webinars which I've kind of watched, and I'm sure you watch as well and kind of be involved with, the costs are slowly going to be coming down with battery technology coming on. That's kind of where the large costs are. And until we kind of see those costs coming down and get the infrastructure in place, I think then we'll see a big rise. And especially with the 2030 date coming up, and Jaguar, I think Ben, you might have shared something on LinkedIn. If you want to kind of share that news with everyone about Jaguar.
Yeah, so yeah, Jaguar did put a marketing piece out not so long ago stating that their plan is for all of their vehicles to be fully electric come 2025, and it's a good thing. The thing with cost is it's linked into volume. So if lots of components, for the sake of argument, if they're making 1 billion batteries instead of 100,000 batteries, I've got dreadful maths there, but let's chuck that out. You're gonna find that that the price of batteries and components go down. So with most new-ish technologies and products that come out, the first versions that come out are always the expensive ones, and then as the wealthy can invest in that, and the company starts making more money, they're able to roll out a slightly cheaper version for the next tiers of wealth that exist within the world, and eventually it just works its way down until all of us are able to afford that technology. So I'm quietly confident that we will see prices come down. It was only, now I don't know anything about this vehicle. I only saw a post on LinkedIn about 2 days ago. However, there was talk about a Chinese import that was being priced at something like £2,500. Now, I wouldn't have thought that would be what we actually see when it really does come to the UK, if they choose to use the UK as a market. But that does mean that there are companies out there that are putting a huge amount of effort into cost-effective vehicles, and probably what we get to see in the real world is somewhere between the two. New cars have never been particularly cheap, have they? And then sort of moving on to like the range anxiety point, it's it's a, you know, it's a valid point. However, the majority of vehicles and the majority of us do not do a lot of long journeys these days. And I mean, me operating my business, I used to be jumping in the car and doing 200 miles one way for a meeting, have an hour and a half meeting, and jumping back in the car and driving back. And quite frankly, it was madness. And for the last year, I've been very fortunate that every single one of my customers now is very much on board with the idea of using Teams as a way of doing meetings, which means I'm not doing long journeys either. I'm exactly the same boat as Tom. I've got a plug-in hybrid too. And I'm barely needing to use the engine, and I've only got a range of about 26 miles. Again, very similar mileage to Tom's. So on the grounds that most of us don't really use vehicles for long journeys, then, you know, especially if you're fortunate enough to be able to plug your car in at home, and I accept there's lots of us that do have to park their cars on the streets or don't have convenient areas to be able to charge, but equally a lot do, then, you know, if you are topping it up at night, then, you know, you could potentially always have a vehicle that's got 200 plus miles of genuine range, no matter what the manufacturers are saying their range is. You know, 200 miles is achievable on quite a lot of the modern high capacity electric vehicles, and I would say that for a huge percentage of society that is more than enough. But we are also seeing the likes of say Tesla putting in long range versions of their vehicles, and I'm pretty sure they've got one that they're able to advertise can do 500 miles. Now, to be frank, I've never had a car that's been able to do 500 miles. About 400 and something has been probably the top of the most efficient cars I've ever owned. So, I mean, if you have got some, you know, if technology goes in the direction where there are options, you know, not all cars will be sold with that many batteries because it's unnecessary, but there will be options for long distance travelers to go for a 500-mile vehicle, and you know, when you're in that sort of realm, especially with fast charging infrastructure, which, you know, in my opinion, without question, is going to keep on being churned out at a rapid rate. You know, no matter what anyone says about the government, one thing I can vouch for is the government did involve all sorts of people from industry in making that 2030 decision. And I know Tom was one of those, and I was one of those as well. We were both at the same meetings together, and they were speaking to lots more important people than me too. But nonetheless, they didn't do it with without thinking it through. So I'm extremely confident that we're going to see a significant growth in charging infrastructure. Things like car parks are absolutely very sensible. You know, putting charging points in supermarket car parks is a wonderful idea, and I think we'll see those sorts of things happening a lot more. It's good for the supermarkets because it gives people a reason to have to stay shopping for an extra 30 minutes or whatever, and you get your charge done in that same period of time. You know, DC charge systems are evolving massively. Of course, you know, Tesla did do a very intelligent thing, in my opinion, with rolling out the supercharger network before they even started really thinking about selling their vehicles. And that does mean long distance business travelers, particularly, would be steered down the direction of that model, that make vehicle, simply because you always know that you're going to be passing past motorway services every 20, 30 miles or whatever, and you're just not going to have a big problem giving it a 30-minute top up to make sure your journey's good. Plus, like the VW group have partnered with some charging infrastructure organizations. I can't remember their names off the top of my head, but they are also having a huge push in these very high voltage charge solutions as well. And you know, the more rapid DC charging we're seeing, the less range anxiety we've got, and then lots of areas to do your little top-ups at your supermarkets, etc., is going to join those two dots together, and jobs are good, and range anxiety is not going to be a problem.
No, brilliant. Yeah, perfect. You know, it's all kind of really good points, and there's so much scope for it, isn't there? You know, the only way is kind of up really with it, and there's so many areas you can look at with, you know, you just say supermarkets, and not many people think, oh, supermarket, yeah, it's a good idea. And there's all these things in the background which, unless you're told about, you have no idea about, you know. And it's good to kind of get everyone together and explain kind of what's in the future and what's coming up, and reduce these anxieties, whether it be range or whatever it might be. If they're future proof, how they're going to be affected in an accident. I see Ben's put a question into the chat and mentioned about how will the repair process of electric cars change when they've had an accident. So obviously we've seen that quite a lot recently with electric vehicles and high voltage vehicles being involved with accidents. And I suppose one thing kind of we need to make sure of is making sure we have enough technicians trained in that area to know that they work on them safely. Because it could be, you know, a fatal accident where an untrained technician who's just come out of college and done just a level 2 in a light vehicle situation and think they know all about these, you know, all about the cars and internal combustion, and then one slight mistake and then that could be catastrophic, you know. So
yeah, well, I mean, I've got a few points on that really. I mean, firstly, electric vehicles are extremely intelligently well designed, and there are various European regulations out there. R100 is a bit of a favourite that keeps coming up in conversations at the moment, where essentially to be able to sell your electric vehicle in Europe, you need to have designed in certain intelligent safety systems. And what that means in summary is that when the unexpected occurs, and there can always be extreme exceptions to this, but they are extreme, and I'm not nervous about using the term extreme. In most cases, and I'm talking in excess of 99% of cases, in my opinion, the onboard safety systems fitted to these vehicles are going to eliminate, or, you know, 99.999% eliminate the chances of a fatal electrocution taking place. So as an underpinning thing, electric vehicles are designed to be safe. And in actual fact, you need to know a hell of a lot about, pardon my language, about that technology to really understand what they've done to make them safe. So it's very easy for people to create scare stories around electrification and high voltage vehicles. However, they are very much designed to protect the passengers and technicians working on them. So, I mean, that's the one point. But the second point is training is absolutely key. Now, I personally, and Tom will be in exactly the same boat as me, as I'm sure yourself will be too, Vinny, is there is absolutely nothing to be nervous about when working on a high voltage vehicle, as long as you know what you're doing. And once you've had that training that ticks off a few key boxes of understanding and truly understanding electricity, how DC electricity flows in a circuit, how AC electricity flows in a circuit, and how to measure it safely, and how to competently measure its absence, that those special relays have opened up and that they haven't, in extreme cases, welded themselves closed when they should be open, and things like that. You know, once you've really got your head around that, they are nothing to be scared of. But if you don't understand and you are randomly carrying out processes of removing casings and things like that covering over the high voltage battery, then that's where you've got to be scared. Now, one final point that I'd chuck in regarding that is high voltage batteries, however, are always there. They are always live. You can't isolate a high voltage battery from itself. So even with all of the high voltage isolation devices and knowledge around high voltage vehicles, even with them being applied, the high voltage battery is still live, and you're always working with this live component. Now, vehicle manufacturers sometimes use things called service plugs, which actually split that high voltage battery in half. So it's quite hard to actually find the terminals you would need to touch to give yourself an electric shock. But nonetheless, there are terminals that are within a high voltage battery which have the potential to kill you if you touch the wrong ones at the wrong time. So that is where the danger always lies. And then the final point regarding accidents and what have you is electrocution is something that we've got to be careful of. But equally, lithium ion can cause us some problems in accidents as well. One problem with lithium ion is if those cells internally get too hot, they will reach a certain temperature, and roughly speaking, I'm going to say 70 degrees C. If the internals of a lithium ion cell reaches about 70 degrees C, it's then starting to be in a range where it can go into something called thermal override, and this is, or thermal overrun. And this is where it will just keep heating up and heating up and heating up, and eventually it will go on fire. And unfortunately, if that one goes on fire, then the one next to it is likely to heat up and go on fire, and that can continue. So that means it's extremely important that the management of the temperature of lithium ion batteries is monitored and managed and taken into account in the case of a vehicle accident. And then the other bit around vehicle accidents that people do genuinely need to be very careful of is lithium, the electrolyte used within lithium ion batteries isn't very keen on mixing with water. And if it mixes with water, some very dangerous gases can come off it. And those gases, if they're breathed in or get it or liquefy on your skin or gets absorbed into your body, can lead to lethal incidents. So that means particularly around the area of high voltage batteries, there does need to be some specific training that is provided to emergency services and roadside responders and those sorts of people and body shops and to a degree technicians, although, you know, technicians in workshops see crash damaged vehicles not that much, but nonetheless there are some dangers, additional dangers associated to that aren't associated to petrol vehicles, with the one final point that I would chuck in, and that's that petrol isn't particularly safe either. It's explosive and it ignites very quickly. So you know, we do have these dangers around electric vehicles, but they're not necessarily any more than a petrol engine vehicle, because petrol's not safe too.
Definitely, 100%. Yeah, not everything is kind of guaranteed to be the safest option out there. So I'm keen to kind of ask one more question, kind of directed to Tom, really. Do you think the electric vehicle world is kind of an attractive proposition to new student or young adults coming through? Are there areas you think that the motor vehicle sector needs to do to promote the electric vehicle world as such? Are we missing something which we're not doing at the moment? Like, in your opinion, really, that's kind of the question I was kind of looking to, hoping you would answer.
We kind of in a chicken and egg scenario here, aren't we? You know, that we know kind of more electric vehicles are coming, but at the moment, I think high voltage electric vehicles, you know, make up broadly about 5 or 6% of the ones that are out there and things like that. But, you know, the announcements, I think just today, isn't it, that Ford are going to stop making internal combustion engines. Volvo are going to stop making internal combustion engines and things like that. This is going to happen, and over the next 10 years, there is going to be a radical change. And as Ben suggested, there will be a radical change in the charging infrastructure and things like that as well. So it is coming. It is coming. And sort of picking up on some of the, the issues about the high voltages and the safety and things like that. One of the ways to really understand complex technologies associated with electric vehicles is to really get hold of the sort of basics before you start. So really understand what voltage means and current means, and what does AC mean and DC mean and things like that. And I'm sure some of the sort of teachers at the college here listening will relate to this, is that sometimes we're trying to explain the intricate operation of the inverter on an electric vehicle, for example, and people haven't always got the basic knowledge of electrics to try and take all of that in. So a message to the students here: this is the future. This is exciting technology. I mean, if nothing else, driving an electric car is much nicer. It's much better than driving an ICE car. They really are nicer. They have a flat torque curve. They will accelerate at any speed and all sorts of things like that. So they are much better, but they are coming. But they're also fascinating. I mean, some of the technologies on these things is just astounding. I mean, we touched on Formula One because obviously Ben has a background in it, and I'm a big fan earlier on. But there are things now like electrically driven turbochargers, for example, high voltage systems that that are being used and developed. And I know that's still linked back to combustion engines and things, but all sorts of fascinating technologies. Now the sort of date is 2030, isn't it, when pure internal combustion cars are not allowed to be sold anymore, but they still will be selling plug-in hybrid cars at that point for at least another 5 years down the line. So these things, aren't going away. But nonetheless, a plug-in hybrid electric car is an even more complex and arguably a more fascinating piece of equipment, because it's got everything that a quality internal combustion car has got, with all the variable valve timing and variable vane turbos and goodness knows what that go along with it. And it's got all the high voltage electric vehicle kit as well. So we're adding a huge extra layer of technology. Now, there's an interesting example, isn't there, as sort of technicians, mechanics, whatever we want to be described as, things getting more complicated. Some people don't like that. They think, oh, I just want to do nice, easy servicing work or something. I think they're wrong. I like things getting more complicated, because the more complicated it gets, it means that those of us that can do it and understand it, like Ben and I and you do, Vinny, we're teaching what we know about these things now. But those people that can work on it, become valuable technicians. And the less work that Mr. Jones can do in his drive at home, the better, as far as I'm concerned. That they have to bring it to experts. And I mean, some of the problems that we're going to have with these things down the line are going to be like really tricky and really interesting, and not dangerous at all, as Ben suggested, if we're all fully trained and we're doing the right thing and things like that. So should you get involved in electric vehicles? Damn right you should. It's the future, it's the way to go, and everything else like that.
And I remember being in a garage kind of when I was doing my apprenticeship and kind of working through that and with Volkswagen, and even speaking to my dad at the time, and kind of said, oh, it's going to be fly-by-wire and it's going to be electric steering. Oh yeah, you have electric steering and it adjusts and stuff like that. And this is all like years ago now. And I don't trust that. No, because what happens if it breaks? But it's normal, and you go with the times, and you have these kind of pushbacks as the technology comes, but it slowly trickles through as being the norm, doesn't it? And kind of unconsciously you kind of just take it on board, and then you get used to it, and that change has happened over time, really.
The day of the Coronation Street mechanic with a big slice of grease on their face and things, I hope, well, they should be long gone already, in my opinion, but I hope that they're long gone anyway. That the people we need for the future are going to be highly qualified, highly trained technicians, and they're going to be highly paid as well.
Yeah, most definitely. And I mean, even we've spoke about the 2030 date kind of a few times today, and you know, the lifespan of an internal combustion engine at the moment is still quite a long time. So it's not going to be 2030, bang, it's done. That's Absolutely. The end of it. You know, we've still got this kind of that merger time, haven't we? It's not going to be overnight, but kind of as we go along the timeline, it's definitely going to. Well, the only way it's going to go is going to go up, isn't it? It's never going to go back now. So, no, I'm very, very thankful to you both, kind of for joining us today and kind of giving your opinions and your technical backgrounds. And I really do hope kind of some of the students can kind of come away with this with more information and maybe something they can relay to their parents or carers or guardians, whoever might be living with at home, and pass that knowledge around, because without these kind of talks, it's very stagnant and things don't really progress, do they? So no, very much a huge kind of thank you from me really to you, Tom, and to you, Ben, for joining us today. And I kind of like to put it out, if any students, you do have any questions before we kind of round up the session, by all means put a little question in. So Damien's come in. So Damien was one of my ex-students, so I've got a question. It's a little bit off topic. Personally, I'm seriously interested in electric vehicles and hybrid vehicles, so I want to go into something to do with electric and hybrid vehicles. So what would you guys recommend? So yeah, I mean, there's lots of opportunities out there, aren't there? You know, the IMI run specific hybrid courses. We can look at CPD events. Damien, in your course, I know you're on level 2 at the moment, so we will be covering hybrids. We've spoken about micro, full hybrids and electric vehicles. That does come up. And I think we've been through it a little bit with me doing some remote sessions on hybrids as well. I think that's where we kind of just touch base of the basics. But yeah, definitely there's lots of opportunities and lots of companies now that do offer the training, and something us as a college are doing is looking at that commercial training and what our local community might need at the moment. I don't think we would aim too high with the diagnostic at the moment. I think we need to start slowly and build it up with kind of safety awareness, and then slowly get into that area when we get there. But no, there's definitely lots of opportunities. And you know, Tom is a bit of a whiz pro with the diagnostics of the electric vehicles and battery systems, etc. So yeah, there's lots out there which you can look up and kind of get involved with. And like I said, it's huge.
Well, look, at the risk of kind of advertising ourselves here, go and buy yourself a decent textbook and go and get yourself a log into our virtual academy and start doing some training and some learning. You know, this is nice, easy sort of steps forward to start learning a little bit more. I mean, Damien's question was not off topic, in my opinion. No. It's absolutely spot on, you know, and it will happen, you know. Can I pick up while I've got the mic, really? Another person, Niobe, I think. If we weren't affecting the environment, do you believe you would stay with petrol vehicles or go electric? I mean, that's a brilliant question, actually. Because, you know, the reason we're sort of going electric is for environmental reasons. And, you know, long term anyway, an electric car is far better for the environment than its petrol diesel equivalent. There's a very complicated story behind all of that, but they really are. Especially if you take into account recycling at the end of life, you know, an electric vehicle can actually be hundreds of times better in the amount of waste it creates and things like that. But if there was a magic petrol engine, would we be going electric? Well, I would.
Me too.
And Ben would. And I mean, in a way, we already have, haven't we? You know, that's because they're better. They really are, you know, a better thing to drive. And I've got to couple it with somebody, I just found it, it's Harry, says, the day I buy an electric car is the day I turn 100. Well, you know, I hope you live that long, Harry, because you're missing out, mate, until that point. You really need to do it. I mean, the thing is, internal combustion engines are not going to go away for like track days and racing and things like that. There'll be all sorts of like interesting things still doing, but for day-to-day use, honestly, an electric car just makes so much sense, really.
Yeah, and especially if you live in a high altitude area, they don't get affected by the less oxygen as well, don't they? So returns to Pikes Peak, you know, with Volkswagen and their car that they made. You know, there's lots. There's, you know, it's the whole conversation, isn't it? It could go on for days and days where we look at the benefits, etc. So keen to answer some of these questions, really. Yeah. So we've got them all flooding in, which is good. So it's nice to see some kind of some questions coming in. So similar to Ben's question, as a body and paint student, are there any extra precautions we need to take when removing electric vehicle panels for painting and repair, or when using in a spray booth? So I suppose, yeah. Ben, that'd be a good one for you, I think, Ben.
I think heat's probably the main one that springs to mind. Well, actually, there's a couple. Yes, I mean, we need to make sure that the batteries aren't getting too hot. So you know, there are instances when it will be important that the battery is not going into the oven, I would suggest. And then in addition to that, I would also be saying that, well, body and paint technicians are more likely to be experiencing damaged vehicles for obvious reasons. Now, then that sort of brings into play things like leaking electrolyte out of high voltage batteries. You know, they're designed to not leak, but you know, if a vehicle's involved in a high speed accident, there is more than enough potential for that to, you know, for their protection panels to fail in one way or another. So, you know, doing things like having an awareness of these extra levels of risk around electrolyte leakage is also very high up on my priority. And also having an overall understanding of high voltage isolation procedures too. You know, purely in the body and paint field, it's, you know, quite common for there to be like an MET technician, which is worrying about the technical side of things before it goes through to the body stroke paint shop. You know, I have to put my hand up. I've never worked in a body shop. I'm only speaking from my understanding of the industry. But I think what's also very important is when it comes to high voltage, it's important to really know that what you're doing is safe, and less of trusting people, but of knowing. And it's when you know that what you're just about to do is safe, as opposed to you presume what you're just about to do is safe, when you are truly safe. So I think, you know, having some additional training in the areas of truly understanding the relevance of high voltage isolation procedures and understanding that they are genuinely safe when working around these high voltage components is an additional skill set that I think is a very important skill that body and paint technicians should understand.
No, brilliant. Yeah, we're getting quite a lot coming through, so I want to kind of get.
Shall I pick up on a couple of the questions?
Yeah, no, definitely, Tom. Yeah, go for it.
I mean, there's some brilliant questions from your students, so that's really nice to see. I'll pick up on Sean's first of all. What about all the lithium mines for the batteries? This is often a thing that's thrown at electric cars, you know, to say, oh yeah, it's all very well, but you've got to mine lithium out of the ground. Well, the implication there is that there's not a lot of mining of oil and crude oil that has to go on, and the shipping it around the world and all the rest of it. So even, you know, yes, we do have to dig lithium out of the ground in different ways to create the batteries. But what's also important to remember is that when we've finished using that lithium, which can be used in the battery in a car, then it can be used for storage, then it can be used for something else, then it can be recycled and put back in the new batteries coming around again. You can't do that with the petrol and the diesel that you're using up all the time. So longer term, you know, I get the point that you've still got to dig lithium out of the ground, but these cars are much, much better overall than all the oil and gas and oil pipelines and oil rigs and all the rest of it. So that was that one. And there was another quick one about hydrogen that I'll pick up on. That a lot of people say, oh, hydrogen is much better for an electric car, but the reason I would disagree with that is twofold, really. One, a hydrogen electric vehicle is an electric vehicle. It is all the things that an electric vehicle has got on it, with the addition of a thing called a fuel cell. And the thing that's often forgotten about hydrogen is that most hydrogen is made from like the oil and petrol industry and the gas industry. So it's not as clean as it first appears. So we either have to up the way of creating more cleaner hydrogen in order to do them, or look at different ways of doing it. But to me, the future of vehicles is definitely the lithium-ion battery in cars. Hydrogen, I think, will become the fuel of heavier vehicles, heavy transport in the longer term. But we could go on a lot more.
Definitely, yeah. I mean, that's what I mean. It's really great to see some of the involvement and the interaction from the students and yourselves to kind of get to the bottom of some of these questions, really. But I'm
a technical one. Sorry, it's just popped up. Where is the battery earthed to? Yeah, well, I think that's a great technical question. So when we think about a normal non-high voltage vehicle, the battery in question is that 12-volt lead acid battery, and the negative post of that battery is connected to the chassis, and that means we only really deal with the positive side of the circuits, and as long as those positive sides of the circuits are earthing back to the chassis somewhere on that vehicle, then those components are going to work. Now, when it comes to a high voltage vehicle, be it or all high voltage vehicles, be it hybrid or full battery electric, we don't use the chassis for earth. We've got a dedicated wire called negative, and that is the one that's connected to the negative post of the high voltage battery, and that negative is encased. It is a special cable that's got a few levels of insulation around it, and sometimes there's some earth shielding in there that is also electrically monitored to make sure that cable is in good condition, and it's that's powering up the inverter assembly. And then I mentioned that you output your inverter, your inverted DC to AC to power the motors earlier on, and all of those three wires that are used to power those motors are also encased in their own cables. There is no use of the chassis for providing high voltage current to any components on high voltage vehicles.
Brilliant. Yeah, perfect. We've got a couple more, I think. Would you say working on electric cars would be easier to work on than petrol or internal combustion?
Well, it depends to me. What do you mean by easier? Like easier, is it easier than changing an oil and filter? I don't know. Or, yeah, you know, are we talking about diagnostics and things? So no, if anything, they're going to become more complex. And as I've said before, I don't think that's a terrible thing. I'm going to very quickly pick up on a couple of other questions that have dropped in here about when will electric cars become cheap enough? I mean, Ben kind of touched on that earlier on anyway, but Volkswagen tell me, for example, that the crossover point of an equivalent ICE car, internal combustion engine car, and an electric car is about 2025. So in about 4 years' time, the prices will become comparable, because new cars aren't cheap, are they? You know, it's not a cheap thing to buy. So I think that's happening. The other one to quickly pick up on is a couple more about hydrogen, really. William, and I mean, these are some brilliant questions, and I'm really sorry, we're not going to get to all of them. Said that Honda had a clean hydrogen cycle where hydrogen was extracted from water using wind or solar energy and then used in the cars and things like that. Absolutely brilliant, yes, and that's absolutely perfect, and let's keep doing that as much as we can. However, it's a matter of scale. It's a matter of being able to scale it up enough so that we have enough clean energy to do that, and the delivery systems for it and everything else that goes on. At the moment, anyway, makes it much more complicated than delivering electricity. Remember, we've already got a way of delivering electricity everywhere we want it to be. If we want a big hydrogen infrastructure all over the country, we've got to put pipes in or tankers or goodness knows what to make it happen. So there's all sorts of complexities going along. But yes, it's wonderful, isn't it, when you can do that? And I think hydrogen might become a good way of storing energy. You know, for example, when the wind's blowing and we're developing more electricity than we know what to do with. We could just make some hydrogen and keep it in a tank for later use. But these are great questions. We need to have another session to pick
Definitely,
up
I'm more than
some of these questions in more
happy
detail.
to kind of get ourselves together again, kind of further down the line. Yeah, by all means, get some more students involved, and it's really good that everyone's kind of coming into here and asking these questions, and it's just all it's doing is just promoting it, isn't it? And everyone's kind of getting their questions answered. But no, I'm going to round it just up there. We're a little bit over, but I'm more than happy running over as long as everyone's kind of got what they need to get from it, really. But yeah, huge thank you, massive thank you. But not only to you two, Ben and Tom, but also to the students for joining in as well. And
brilliant questions. Thanks, guys.
Lovely day. And by all means, I'll get some hopefully get some feedback from the students from their tutors, and if there's any areas that pop up which they might want to discuss, we can look at kind of running something again in the future. But yeah, no, brilliant. Thank you so much. And just kind of a bit to the students, really. Next talk we've got, you'll probably a bit bored of my face now, really. But anyway, you'll have to put up with me for another hour. Is at 2 o'clock today. You should have the link from your tutors, and it's